Now in this lecture I am going to discuss matrix multiplication. Once I will tell you what is matrix multiplication. After that I will tell you how can we apply the logic of going for matrix multiplication, and in the next lecture I will go for the algorithm and the implementation part of this. Okay, matrix multiplication. What happens in matrix multiplication is there are two matrices and we are supposed to multiply them. The logic of multiplying is entirely different from that of matrix addition. Now what happens is first we choose the row of the first matrix, and what we will be doing is we will be multiplying the first element of the first matrix, that is the element at the first row, first column. We will be multiplying it with the element at first row, first column of the second matrix. After that, we will change the column of the first matrix and we will multiply it with the element which is at the second row, first column of the second matrix. Then we will choose the element which is at the first row, third column of the first matrix, and we will multiply it with the element which is at the third row, first column of the second matrix. Now, after each multiplication, we will be adding them together. Okay, so that will be getting the first element of the resultant matrix. Here resultant matrix means that the matrix that will be containing the result of this matrix multiplication. For example, see, when I do 1 into 2 plus 2 into 1 plus 3 into 3. So what will happen is I will get 13. I will get 13. What is 13? 13 is the first element of the resultant matrix. That is the element of first row, first column of the resultant matrix. Okay. Now what we will do is we will not be changing the row of the first matrix, but we will be changing the column of the second matrix. So what we will do is, again, what I will do is I will choose the first row, first column element of the first matrix and multiply it with the element which is at the first row, second column of the second matrix, because I am going to traverse second column now of the second matrix. So I will get 1 into 1, 1. After that I will choose the element which is at the first row, second column of the first matrix. I will multiply it with the element which is at the second row, second column of the second matrix. Okay. Then I will choose the third element and I will multiply it with the element which is at the third row and second column of the second matrix. So now what will happen is, again see, 1 into 1 plus 2 into 4 plus 3 into 5. So you will see I will end up getting 24. So this is the element of the resultant matrix, the element which is at the location first row, second column. Again, I will not be changing the row of the first matrix, but I will be changing the column of the second matrix. So what I will do is 1 into 3 plus 2 into 6 plus 3 into 7. After that, I will get 36. So I have got the element of the resultant matrix, the element which is at the first row and third column, right? So now we are going to get the second row of the resultant matrix. In order to do that, what I will be doing is I will be switching to the second row of the first matrix. And again, in the same process, I will be multiplying the elements of the second row of the first matrix with the elements of the columns of the second matrix. So again, see, 4 into 2 plus 5 into 1 plus 6 into 3. So you will see I will end up getting 31 in this example, right? So again, I will not be changing the row of the first matrix, but I will be changing the column of the second matrix. So I will write 4 into 1 plus 5 into 4 plus 6 into 5, and you will see I will get 54. Again, I will not be changing the row of the second matrix, but I will be changing the column of the second matrix. So what I will do is 4 into 3 plus 5 into 6 plus 6 into 7. So when you will calculate, you will see that it is 84. Okay, so now you have understood that we have got the full second row of the resultant matrix. Now what we are going to do is, you can easily judge it, you can easily guess it. We are going to switch to the third row of the first matrix, and again we will be starting from the first column of the second matrix. So again, 7 into 2 plus 8 into 1 plus 9 into 3, so that will give you 49. We will change the column and same row will be there. With the same process, we will get 84, then we will get 132. So this is how the matrix multiplication takes place. Now, thinking about the logic of applying matrix multiplication in an algorithm and in a program, see carefully how we will be applying the logic. As you can see in this process, what is happening is, when we people use nested loops, the outer loop or the outermost loop is the loop that is executed the least number of times, and inner loops, they are executed more frequently. So what is the thing that is taking place very slowly, I means very less frequently? As you have seen, that process was changing of the row of the first matrix. So we will be using the outermost loop for changing the rows of the first matrix, right? Then, as you can see, we will be applying the middle loop. Of course, it is a nested loop. I am calling it middle loop because there will be yet another nested loop. So what we'll be doing is, we will be using the middle loop for traversing the columns of the second matrix, right? And what is the thing that is happening the most frequently? As you can see, this is nothing else but the changing of the columns of the first matrix and changing of the rows of the second matrix. For example, in the first case, what I did was 182 plus 2 into 1 plus 3 into 3. As you can easily see, that the most frequently executed process was the changing of the columns of the first matrix, because we are not switching the row very frequently, but we are changing the rows of the second matrix very frequently, of the second matrix. So changing of the columns of the first matrix and changing of the rows of the second matrix, this is the thing which is taking place the most frequently. So in order to do this, we will be applying the innermost loop, right? Okay, let me show you this thing that I have explained to you. You can write it down. Logic of matrix multiplication. This is the thing that I have explained to you. 3 loops will be applied. Outermost loop for traversing the rows of the first matrix. Again, let me repeat that outermost loop is executed the least number of times. As you can see, the number of the rows of the first matrix are being changed very less frequently. The least frequently executed thing is change of rows of the first matrix. That is why outermost loop will take care of this thing. Middle loop for traversing the columns of the second matrix. Innermost loop, that will take care of the thing which is taking place the most frequently, and that is the columns of the first matrix and rows of the second matrix, right? So in the next example, I am going to show you the algorithm as well as the implementation program of matrix multiplication.